This is Dr. Ryan Johnson. This is Introduction to Statistics, section 11.2. In this section, we're looking at the draft lottery. So this is from 1970. This was in the middle of the Vietnam War. And so there was a draft lottery. So each of the 366 birthdays, because you include the leap day, was assigned a draft number. Young men born on days assigned low draft numbers were drafted. So we'll regard the 366 days of the year as observational units. We'll consider two variables recorded on each date: draft number, assigned to the date, and sequential date in the year. So January 31st is number 31 of the day of the year. February 1st is the 32nd day of the year, and so on and so forth. So in a perfectly fair random lottery, what should be the value of the correlation coefficient between draft number and sequential date of birthday? So you just use your common sense knowledge of the world there. So the figure below displays a scatter plot of the assigned draft numbers and the sequential dates. There are 366 dots, one for each day of the leap year. Okay, a scatter plot of the data. So let's number 2. Let's take a look at the scatter plot in the figure. Does the scatter plot reveal much of an association between draft number and sequential date? Do you see any trend there? Well, answer that. Well, for part B, based on the scatter plot, guess the value of the correlation coefficient. So just give a good guess. Does it appear that this was a fair random lottery? Use your common sense knowledge of the world there. We're trying to connect statistical things to things that are calculated. Okay, it should be difficult to see much of a pattern. So here, the 1970 draft lottery data sheet below shows the draft number assigned to each of the 366 birthdays. So there's, I think I might need to zoom out. Yeah, okay. So there's the date of like 1, 2, 3. So for instance, let me go down further. Find and report the draft number assigned to your birthday. So for instance, my birthday is May 15th, so I would find May, and then 15, and so that's my draft number. Okay? So as you report your draft number, is it in the bottom third, middle third, or top third? Okay. So the second table has the draft numbers in order for each month. So then this ranks them in order for each month. So for instance, so this is kind of like the draft numbers for May, the draft numbers for February, the draft numbers for January. Okay, use this table to determine the median draft number for your birth month. So pick your birth month. I would pick May. And then May has 31 days, and so the 16th day is in between, like, because 31 is like 15 plus 1 plus 15. So then the median draft day for my month would be right there in the middle, 226. Okay? Well, if we were doing this in class, I would have you guys work together, but you're all going to have to do it separately. So collaborate with you just have to do it by yourself. Determine and report the median draft numbers of all 12 months. There's a kind of a knack to it is that for the months that have 31, you just pick there. The months that have, so February has an odd number as well, so it's going to be there. And then the ones that have 30 days, you need to take the average of the two, and so on and so forth. Okay? All right. So do you notice any pattern or trend in the median draft numbers over the course of the year? So if you don't see a trend, compare the 6 medians from January to June and the 6 medians from July to December. Okay? The correlation coefficient for the full data set is negative 0.226. What does this number reveal? Is it consistent with the scatter plot? So negative 0.226. So it's hard to see it here, but notice how they're numbers are clustered around here and clustered around here, and they're more open there and more open there. And so you've got this broad this way. Okay, so use a full sentence or two to answer that question. All right, let's think about how we would complete a test of significance for correlation. So suggest two possible explanation hypotheses which would generate the value of the non-zero correlation coefficient. Okay, so you should have seen these two hypotheses in the Xi book. So you saw this right underneath step 4 in the Xi book, where it said the null hypothesis is that no association exists between, in that, like their situation there. The alternative hypothesis is that there is an association. Okay, so your answer should be similar, but with our data from the worksheet. Okay, so B, in your own words, how can we go about determining whether the random chance is a plausible explanation for the observed correlation between sequential date and draft number? Explain how the 3S strategy could be applied here, in particular identifying a simulation strategy you could conduct by hand. Like come up with some random strategy, like pulling things from a hat or things like that. You don't actually have to carry this out because it'd be you can come up with something that would take a long time. That's okay. All right, so part C. Also for part B, use full sentences, please. For part C, what is the statistic? How would you simulate? How would you evaluate the strength of evidence? Okay, so the statistic is the single number that we're using to describe the sample. There's a good hint here. It's in the title of this section. Okay. Now, so the null hypothesis to be tested is that the lottery is conducted with a fair random process. So the null hypothesis is that there would be no association. Alternative is that there was not conducted fair, not a random process, so there is association. So how can we assess whether or not negative 0.226 is far enough from random? Well, we can check out how it adds up. So we're going to go to the correlation coefficient applet. I still have it open from making the video for the last section. So then you can choose the data draft lottery. Use data. Okay. All right. Correlation coefficient box. Yep. There we go. Press shuffle Y values 4 more times. All right, check the shuffle options. So we got to go over here. Show shuffle options. Try to say that 5 times fast. All right, and then record. So then shuffle your values. Yours should be different from mine. Okay. No, I needed a statistic. Okay. Okay, so we got a good warning that I forgot to choose what statistic we're looking at, and we're looking at correlation. Okay, so record what you got. So for mine, I got most recent shuffled correlations this, which actually is this. And then you should record yours. And then for part B, do it 4 more times. So 1, okay. Record all those values. So I've got, I would record this one, I would record this one, and this one. Okay. Did any of your simulated statistics from fair random lotteries produce a correlation coefficient as extreme as negative 0.226? Well, let's look here. Mine go from about -2, negative 0.10 to a negative 0.04. So no. Change the number of shuffles from 1 to 995. 995. Shuffle Y values. Okay. And where is this distribution centered? Why does this make sense? Okay. Now it's called the null distribution. That's a good hint. All right. So for part E, next to the count samples box, choose beyond. So I would go to it might be good to like copy this number. So copy that number and then go here, go there. You want to go beyond, count them up, and sometimes it can go a little slow, but I don't know what's going on here. I might just, well, I'm going to restart. Okay, I reloaded my page and it worked again, so I don't know what was going on. So now when I look at how often I got a correlation coefficient of negative 0.226, when I ran it, I got 0. You might get 1 or 2 when you run it, okay? So report your p-value and then interpret the p-value, the probability of what, assuming what, okay? So for part G, what conclusion would you draw for this p-value? Do you have strong evidence that the 1970 draft lottery was not conducted with a fair, random process? Explain your reasoning behind your conclusion. Okay, so write this one in full sentences. It should be probably more than one full sentence, maybe 2, maybe 1. Maybe you can fit it in 1, who knows. All right, so exploring further. Once they saw these results, statisticians were quick to point out that something fishy had happened. The irregularity can be attributed to improper mixing of the balls. You guys remember seeing like one of those crank things with like ping pong balls with numbers on them? So the balls that had later in the year were placed last, and so the mixing process wasn't very good. Okay, so then the next year the correlation coefficient was 0.014. So use your simulation result to approximate the p-value for the 1971 draft lottery. Is there any reason to suspect that the 1971 draft lottery was not conducted in a fair random process? So go ahead and change this number. Instead of using this number, use the number from the 1971 draft and put that into the applet and see what you get. Report on that, finish answering the question, and that is the last question from this section.